Hello and welcome to a video on angles in triangles. Now these are not angle pairs. These two rules that we're going to see are about three angles. The first one is about the three interior angles of the triangle. We can just call these this one, and this one. The three interior angles. They always add up to the same sum, and that's always 180 degrees. And that is called the triangle sum theorem, sometimes called the interior angle sum theorem, but you can see here the name. Okay, the other one is called the exterior angle theorem, and it's also about three angles, but it's not about the three angles inside of the triangle. It's about one of the angles on the outside. Now, so we have a little quick little explanation here. Is we have two things that add up to 180. We have the linear pair here. These two angles right here add up to 180, and these three angles add up to 180. So it makes sense that this angle right here, let's call this angle 4. This angle is the supplement of angle 1, right? Because that's a linear pair. But it's also the supplement of angles 2 plus 3, because that also adds up to 180. So it makes sense that since it's the supplement of two angles, two things that are the same, that those things must be equal. In other words, the exterior angle, the angle formed when you extend one of the sides of the triangle, it's called the exterior angle. I'm just going to draw it by actually taking one of the sides and extending it, and then seeing how that forms an angle on the outside with the triangle. That's called an exterior angle. And the rule is that the exterior angle is equal to the other two, the two remote, we call them sometimes the remote interior angles or the non-adjacent interior angles. So angle 1 is congruent, is equal to the sum of the measure of angle 2 plus the measure of angle 3. Those two add up to angle 1. All right, so those are the two rules we're going to practice using right now. We're going to do some of the problems on here, not all of them. All right, the first one, we're looking at three angles inside of a triangle, and we know that they add up to 180. So we could just write a simple equation. And we're just going to get used to writing the equations like this, because once we get to the algebra part, we need to write equations like this. Even though these are just numbers, we're going to write them as an equation. So we know that, we'll call this one x, okay? We know that x plus 24 plus 37, that all adds up to 180. All right, so we're going to have a calculator handy when we're doing this. We're going to add the 24 and 37. That adds up to 61. So we know that x plus 61 equals 180. Subtract 61 from 180, and you get 119 degrees. Okay, let's look at number 2. Now this time we're not looking at the three angles inside the triangle. We're looking at that second rule that says that these two angles add up to the third angle. They're equal to it. So what we know is that the measure, let's call this x again. Okay, let's not call it measure of angle. It just makes it a little easier. All right, we know that x is equal to the sum of the other two. So 76 plus 52 adds up to 128. All right, let's look at one more. Now this time we know we have another exterior angle. So this is kind of like the angle 1 up here. I'm not going to call it x because I know it's 104 degrees. I'm going to call this one x because this is the one we're looking for. And I know that 104 is equal to the sum of the other two, so x plus 79. All right, I can subtract 79 from 104. So 104 minus 79. Don't feel like doing that one in my head, is 25 degrees. So measure of angle 1 is 25 degrees. All right, let's look at the next one. These get more interesting when you have more figures in the diagram, so let's look at one like that. So in this diagram, we have three triangles, but we're going to start out by looking at this triangle on the left. Why? Because I see, whatever you see, that's where you have to start. I see that there's the three angles and I know two of them, so I can find the third one. So I can start out with that triangle by saying that, let's call this x, okay? So I know that x plus 66 plus 84 adds up to 180. Adding these two together, I get x plus 150 equals 180, and so therefore x equals 30. Okay, so I'm on my way. So angle 1 is actually x, so angle 1 is 30. All right, so what else can I do? Well, I have to not only use triangle rules. Once we get to this point in the class, we're going to start to really combine the different things that we know. So I'm going to switch gears now, and I'm going to look at this linear pair right here. Why? Again, because that's what I see. I could have started there. That could have been my first step. Whatever you see that you know a rule for, you're going to use that. Sometimes it'll be vertical angles, like in number 6. I think it would be a good idea to see those vertical angles and maybe start there. Okay, so I know that these two add up to 180. So let me just shrink this a little bit. So I know that 180 minus 84 is equal to 96. So this one is 96. So that goes there for angle 3. And now that I have one more triangle here, so I have this purple triangle now, this whole triangle. Now that I've done those other 2 steps, I realize, wow, I know 2 angles of that purple triangle, and the 3 angles add up to 180. So let's just call this one y, and I know that, I'll squeeze it in here, y plus 96 plus 43 equals 180. So that means y plus 159 equals 180, and subtract 159 and we get 21. So y is 21 and y is angle 2, so this is a 21. Okay, so did anybody see my mistake? My adding mistake right there, that does not add up to 159, that adds up to 139. And so when you subtract that, you actually don't get 21, you get 41. So this is 41. Doesn't change anything else. Okay, let's go on to number 7. Number 7, we have a bisector. So we're going to have to use that word bisector and remember what that means. So we know that BC bisects ACD. That means it cuts it in the middle, makes 2 equal parts. Well, it so happens that angle ACD is a 90-degree angle. So if I make that into 2 equal parts, they each have to be 90 divided by 2. They each have to be 45-degree angles. So I already know angle 2 and 3 are 45-degree angles just from that statement. Don't need anything else, just because it's already given to be a right angle. So I already know angle 2 and 3. 45 and 45. All right, where can I go from there? Well, I see now that there's 2 triangles, and for each of those 2 triangles, I know 2 angles. So I can start out with this triangle, and I can use that to get angle 1. All right, so now I can just kind of look at this as these 2 angles add up to 48 plus 45 is 93. So 180 minus 93. I'm just doing this without the equation because it's okay to do that as long as we don't have variables all over the place. And this is, let's see, 87. So this is 87 degrees. So angle 1 is 87. And now let's look at the last triangle over here. So this triangle has a 45 and an 83, and they add up to 128. And 180 minus 128 will give us angle 4. And that is 52. Right there is 52, so angle 4 is 52. Okay, let's add on one more level of complexity before we add some algebra to these. So let's look at number 10. All right, so number 10, I see at least 4 triangles in the diagram. I see this triangle on the top, on the left, on the bottom, and then the one that forms half of the rectangle. All right, so let's see what we have here. We don't have any directions, so there's nothing there except what's already marked. We know those right angle symbols are all 90 degrees, so I'm just looking for something that I already know enough of that I can find an angle. And so, well, my eyes are going down to here. Whoops. My eyes are going right down to here. I know that these 2 angles add up to 90. And I already know one of them is 52. So this is going to be 90 minus 52. That's 38. So I've got a start. Okay, angle 6 is 38. And again, in these kinds of problems, you have to start wherever you can. You got to look for something that makes sense. Don't try to start with angle 1. Just start with something that you can start with. So I've got angle 6, it's 38. And also be really careful, because if you make a mistake early on, it can go with you for the whole problem. You can end up missing everything. So just be really careful here. Now I've got a triangle. I may as well show this red, I'll make it blue, show this triangle here because now I've got a triangle which has 3 angles and I know 2 of them. So I know these 2 angles, 38 and 86. You see, if I didn't get that 38 wrong, I'm going to mess up everything else, but I did get it right. So that's 110, that's 124. And then I need to go 180 minus 124, and that's going to be 56. Okay, so angle 5 is 56. I'm on my way. Okay, angle 5 is 56. Let's switch gears here and notice that now that I've got angle 5, I've got another one of these right angles and adds up to 90. So this angle 1 in here is going to be 90 minus 56. So 90 minus 56, and that is 34. So I finally got angle 1. You always want to start with angle 1, but you just can't always do it. So this is 34. All right, where can we go from there? Okay, well, I see another place I could have started. I started down here with angle 6, but I'm now seeing that I could have started right here with the linear pair. You see the linear pair? 86 and 4 has to add up to 180. So 180 minus 86 will give us angle 4. Okay, so that's 94. So angle 4 is 94. All right, let's keep going. We got a new triangle. You see the new triangle up here? That whole thing up there? Well, I have 2 of the angles on that one. 34 and 94. I almost covered them up so I can barely see them, but 34 and 94 adds up to 128, and I can subtract 128 from 180 to get angle 2. So 180 minus 128 equals 52. That's angle 2. Wow, I only have 1 more. Almost done. It looked a lot more complicated when we started. All right, so I have 90 minus 52 to get this angle right here because it makes another right angle. I'll just highlight that in blue again. So this is another right angle, makes 90 degrees. So 90 minus 52, that's 38, and we're done. Okay, so we've got a bunch of examples here. Remember that there are 2 theorems. There's 2 different rules here that we can use. Most of them tend to use the angle sum theorem, the ones with interior angles, but just remember we also have the exterior angle theorem like example 2 and example 3, and that does come up every once in a while in these problems. So don't, when you're struggling, sometimes just remember there's that second theorem. Okay, part 2 will be setting up algebraic equations and using algebra with these 2 theorems. Okay, hope you found this helpful.